Chemical reactions are all around us, from cooking food to rust forming on metal. But have you ever wondered what's really happening during these processes? Let's dive into the basics. A chemical reaction is a process where substances, called reactants, are transformed into new substances, known as products. These changes are often irreversible and involve a change in state, color, temperature, or even the evolution of gas. Think about how rust forms on iron or how milk turns into curd. All of these are chemical reactions. Now, what are reactants and products? Take the reaction where magnesium burns in air. Magnesium and oxygen from the air are the reactants, and magnesium oxide is the product. It's written like this: MgS plus O2G MgOS. This leads us to chemical equations. These are a shorthand way to represent reactions. But why do we need to balance them? Well, according to the law of conservation of mass, matter can neither be created nor destroyed. That means the number of atoms on both sides of the equation must be equal. Here's an example of how to balance an equation. Fe plus H2O Fe to O3 plus H2 when balanced. It becomes 2 Fe plus 3H2O Fe to O3 plus 2H2. Now, let's talk about the types of chemical reactions. First, there are combination reactions, where two or more substances combine to form a single product. An example is when water is added to quicklime. Chow plus H2OCaOH2. Then, we have decomposition reactions, where one substance breaks down into two or more. For instance, when ferrous sulfate is heated, it decomposes into ferric oxide, sulfur dioxide, and sulfur trioxide. 2 FeSO4 Fe 2 O3 plus SO2 plus. SO3 decomposition can also be driven by electricity or light. A classic example is the electrolysis of water. 2H2O2H2 plus O2. Next, we have displacement reactions, where a more reactive element displaces a less reactive one. For example, Fe plus CuSO4 FeSO4 plus Cu, and double displacement reactions, where the ions of two compounds are exchanged, such as when sodium sulfate reacts with barium chloride. Na2SO4 plus BaCl2BaSO4 plus 2NaCl. Then, there's redox reactions, where oxidation and reduction occur together. For example, 2Cu plus O22CuO. In this reaction, copper is oxidized to copper oxide. Chemical reactions affect our daily lives too. Ever noticed how iron rusts, or how food becomes rancid when exposed to air? These are oxidation reactions. Finally, reactions can either release energy, like when coal burns, or absorb it. When coal burns, it releases heat. C plus O2 CO2 plus heat, and when calcium carbonate decomposes, it absorbs heat. CaCO3 Chow plus CO2. Chemical reactions are at the heart of everything, from the food we eat to the air we breathe. Understanding them helps us appreciate how the world around us constantly changes.